We will be skipping question 7 because that is about the topic moments that we have not covered. Question 8. Figure 6 shows an unusually shaped container. The container has 4 vertical tubes of different shape and size. Here we have the container and the 4 different shapes. Water is poured into the container up to the level shown in tube 1. Complete the diagram above to show the height of the water in tubes 2, 3 and 4. As we know, water will always keep the same level. So in the case of tube 2, 3 and 4, the levels should all be in line with the water in tube 1. So there the levels should be all at the same height. Remember, the width or the shape of the tube does not make a difference. The only thing that makes a difference is the height from the bottom of the water. Question B. The further a swimmer dives below the surface of the sea, the greater the pressure on the swimmer. Explain why. According to the equation for pressure in liquids, which we said is P equals H rho G, the further below the surface you go, the greater the pressure, since they are directly proportional. We had said that pressure in liquids depends on only 3 things: the height or the distance from the surface, the density, and the gravity. Now, the gravity you cannot change as you go. The density you cannot change as you go either, but the depth that you are in, that can be changed. Question C. A person swims from a depth of 0.5 meters to a depth of 1.7 meters below the surface of the sea. Calculate the increase in pressure on the swimmer, given the density of the sea is 1030 kg per meter cubed. So for this question, we must first calculate the pressure at 0.5 meters, and then calculate the pressure at 1.7. So starting off from the equation, P equals H rho G, the height is 0.5, density we've been told is 1030, and G we've been told at the beginning of the paper we should take it as 10. So let's plug in the values. So 0.5 times 1030 times 10, that will give us 5150 pascals. Now, we have to work out the pressure at 1.7, and we will do that by once again starting from the equation, plugging in the values. This time instead of 0.5 we will have 1.7, so 1.7 times 1030 times 10, which will give us 17,510 pascals. We cannot stop here, because we've been asked to find the increase in pressure, not just the pressure. And in order to do that, we have to find the difference between 17,510 and 5,150, which means we simply have to minus. So the increase in pressure is 17,510 minus 5,150, which gives us an answer of 12,360 pascals. Question D. Figure 7 shows a hydraulic machine that is used to lift a diving cage into the sea. And we have the diagram of the system with the master piston, the slave, and their cross-sectional areas so that we can work out any questions we are given. The pressure applied to the hydraulic liquid at the master piston is the same as the pressure applied by the hydraulic liquid to the slave piston. Question 1. State the property of the liquid that keeps the pressure at both pistons the same. And here we are going to refer to the fact that liquids are not compressible. So this implies that if pressure is applied on one side of the liquid, then that pressure is going to be transmitted throughout the whole system. Question 2. A 360 Newton force acts on the master piston. Use the information from figure 7 to calculate the force applied by the hydraulic liquid to the slave piston. So in this case, even though this is regarding pressure in liquids, but you have to keep in mind that this is about hydraulics. And whenever we have hydraulics, we have to use the equation pressure is going to be equal to force 1 divided by area 1, which also has to be equal to force 2 divided by area 2. Now if we go back to view the diagram, we have force 1, which is 360 newtons, we have area 1, and we have area 2. However, we do not have force 2, which is what we have to find. So we have to get force 2 subject of the formula, first and foremost, and to get force 2 subject of the formula, we have to get rid of area 2 and send area 2 over onto the other side. This will result in F2 is equal to F1 multiplied by A2 divided by A1. So the force on the slave piston is equal to the force of the first piston multiplied by the area of the second piston divided by the area of the first. Now that we figured out the subject of the formula, we can simply plug in the values. So F1 we said is 360, A2 is 0.28, and A1 is 0.0012. This will give us an answer of 84,000 newtons, or else 8.4 times 10 to the power of 4 newtons. And that completes question 8.